Yeah, so good evening, everyone. Welcome to the third week live interactive session of Advanced Computer Network course. So we'll quickly go through what was the topics covered in the previous week, like week 3, and then we'll also look at the previous year's assignment question so that it will help you solve this year's assignment. Okay. So I hope my audio is clear and also the screen is visible. Can someone just confirm once? Yeah, thanks. So, right. So, we'll get started. Yeah. So, basically, in this week, the major, one second. The major topic that was covered is packet classification and the various algorithms or data structures used for the packet classification. So before getting into what packet classification is, let us first see why we need packet classification, and then we can go into the algorithms, the different classification mechanism that was discussed. Okay, so why do we need packet classification? So as explained in the lecture by the professor, so we know that current internet is designed to perform in a best effort manner, right? So best effort manner means that it will only try its best to make sure that the packet that I send gets delivered to the destination. There is no guarantee that I will get so and so Mbps rate, or my packet will be delivered so and so. So either it's the routers also works on a best effort manner. If they get a packet, if there is a space in the buffer, the packet will be saved in the buffer. It will be retrieved. Route lookup will be done, and it will be forwarded. But if the packet arrives and at that time, if the buffer is full, then the packet gets dropped. That's how it works. But if we want to provide some privilege to certain applications, for example, the current application that we're using, it's a video call, right? So there is no point if you hear me after with a delay, or if you can't see what I'm writing in a real time, this whole Google Meet, this live streaming will not work, right? So for certain applications, it is important that we need to provide certain quality of service to these applications. So to ensure that QoS or quality of service can be provided, we need what is known as packet classification. That is, if the router have to process, when we say quality of service, we mean that for certain packets or certain packets of certain application will be processed in a certain way, and packets of the other set of application will be processed in another way. So there will be it's not like all of them will be processed in the similar way. There can be certain bandwidth guarantees provided. We can some priorities can be assigned to the packets of certain applications, so that routers will process them accordingly. So if this has to be done, first of all, the router should be able to identify the packet that belongs to that particular application, right? So for identifying the packets, we need what is known as classification mechanism. So how do we identify a packet of a particular application? So let's take an example, like from source S1, there is a destination D1, and there is a source here, okay? And a packet is being sent, and it goes through multiple routers, okay? So now when and maybe let's assume that this is a Gmeet app from S1 to Gmail doesn't work in one-on-one. It will be a different architecture, but just assume. Okay, let's not assume this. So there is a communication between S1 and S2. Okay. So now if the router have to identify all the packets from S1 going to S2 and also vice versa, we need to to have a mechanism to represent the packets pertaining to this particular communication. Okay, so we do that using a terminology called flows. Okay. In general, all the when a communication happens between a source and a destination, that all the packets belonging to that particular communication initiated by that application can be identified using what is known as a flow ID. So, in general, a flow ID is represented by a 5 tuple. It comprises of source IP, destination IP, source port, destination port, and the protocol. So um, when we need to achieve this quality of service, what we have to do is we need to mention the classification. We need to tell the router that if packets comes with so and so rules or in so and so manner, this belongs to this particular application and it has to be processed in certain way. So to tell that, we have what is known as, to help that, we have what is known as classifier. So this classifier is nothing but a set of rules that will help the router identify to which class this particular packet belongs to. So that accordingly, the corresponding QoS and other aspects can be applied. Okay, so classifiers is nothing but set of rules, and in general we represent rules in this manner. We in the lecture, these are called as dimensions. So a normal normally the rules comprise 5 dimension: source IP, destination IP, source port, destination port, and protocol. Okay, so we represent, like for example, if I want to identify all the packets belonging to a particular application sent across S1 and S2, I will write a rule that will segregate all those packets. So that particular rule will be the classifier. Okay. So when the router will, for rules like R1, R2, R3, router will look into these rules and then it will classify. Okay, this packet belongs to this rule. This packet belongs to this rule. So if it belongs to this rule, it needs to be processed in so and so way. So that is the significance of packet classification. Okay, I hope this is clear, because otherwise there is a obvious question, why are we doing all this try and other things. Okay, so this is where the packet classification comes into picture, for that to help the routers classify the packets such that the quality of service and can be applied on it. Okay. So to classify, I'm not getting into the requirements and other aspects of packet classification. We can just see what are the available, like what are the various algorithms discussed in the class, and then we will go to the questions. Okay. If you have any doubt, you can either raise your hand or you can put it in the chat, or you can unmute yourself and ask me. Right. So the different types of packet classifier or packet classification algorithms are, one is the or representation is, one is the hierarchical, right? The second one is anyone? What were the various packet classification implementations discussed? Set pruning try. The other one is grid try. Then the one is field level try. Right? Any more? Or that's all? Right? So let's quickly go through some examples how the rules are represented in this mechanism. Okay, so classifiers help the routers to classify the packets so that on top of it we can apply the QoS necessary priority, scheduling, bandwidth management, all those aspects. Okay, we'll see how those rules are normally in the form of like um, 10.10.10.1 to 20.20.20.1. If it is port number 5, you deny this or you allow this or give priority as XYZ. So this forms the source IP, destination IP. It's not mandatory that always all the 5 dimension has to be there. Couple of dimensions can be, sometimes it can be 20.10.10, it can be star. So couple of dimensions can be wildcard as well. Okay. So let's now take an example of how this particular rules, given a set of rules, how do we represent it using a hierarchical trie. Yeah. So example, R1 is given as we have 2 dimensions for the rules D1 and D2. R1 is given as 0, 0 star, and D2 dimension 2 is also given as 0, 0 star. For R3, dimension 1 is given as 1, 0 star, and dimension 2 is given as 0 star. For R3, the dimension is 1, 0 star, and D2 is 1, 0 star. R4 is 1, 1 star, and 1, 1 star. Okay, so how hierarchical trie represents this? We have already seen in the previous class how, given a prefix, how do we form a binary trie. So in when we have multiple dimensions, we are building one trie on top of another. For like if we have n dimensions, we will have n tries built on one on top of another. So for D1, we will have a trie. For D2, we will have another trie. For D3, we will have another trie. Like that, we build one on top of it. So that is this concept of hierarchical trie. So first we will build for D1, then we will go for D2. So for D1, first we start with the root node. So R1 is 0, 0, 0, and this is R1. So 0, 0 star is R1. R2 is 1, 0 star. 1, 0, 1, 0 star is R2. R3 is again 1, 0 star. So it is R2 and R3. R4 is 1, 1 star. Okay, so we have constructed the trie for the first dimension. 0, 0 for R1, 1, 0 for R3 and R2, and 1, 1 for R1. Now for the second dimension, how we do is we just take a dummy link to the second root of the second trie. From all the n nodes, we'll have a dummy node to the root of the second trie, and then from there we'll construct it as if like normal trie. So again for dimension 2 we will construct. So R1 have D2, so D2 has 0, 0 star. So from R1's dimension 1 we are here, then from here we will have a dummy link to the root of the second trie. And from here, now what is the prefix? 0, 0. So again, we have a 0 followed by a 0. And what is this? This is again R. Now for R2 and R3, for R2, the prefix is 0 star. And for R3, it is 1, 0. It is 1 followed by 0. This is R3. Now for R4 it is 1 1 star. 1 1 1 star. So this is how a like for a given, this is a rule, or we can tell this is a classifier. So given this particular set of rules, this is how we represent it using hierarchical trie, and we are not mentioning the action here. Okay, whatever, whenever a packet comes, we will retrieve these dimensions from the packet. So here, for example, this is source IP and destination IP prefixes. So when a packet comes, the router will retrieve the source IP and destination IP, and then it will traverse through this particular trie that we just constructed. And if any of the rules matches, corresponding action will be taken for that particular packet. Okay, that we have not written and we are not mentioning it. We are just looking at how the implementation of this packet classification or the classifier. Okay, so now assume that we have a packet which has a prefix of 00. Assume that we have a packet with source IP 00 star and destination IP, or D1 as 00 star and D2 as 11 star. So now what we have to do, we will traverse from the start. Okay, 0 0. So it comes here. From here it will go to the second dimensions try. So there do we have a uh, um, do we have a rule for 1 star? We don't have, right? So this will not be matching. Okay, now assume that we got a packet with the prefix 10 star D1 and D2 as 10 star. So what we will go here, 10 star. So R2, then we go to the, for D2 it is again 10 star, it is 10. So this rule R3 matches for this packet. So based on the action mentioned for that particular rule, this packet will be processed. If it is to ensure that put it in a high priority queue, that packet will be put into the high priority queue, so it gets scheduled faster and the packet gets sent out faster. Okay, so this is one example. Let's take maybe one more example. So these examples are all the ones discussed in the lecture by the professor. Another example, R1, R2, R3, R4, R5, R6, R7. 00 star, D1 and D2. 00 star, 10 star, 0 star, 0 star, 0 star, and star. Now 110, 11 star, 1 star, 01 star, 10 star, 1 star, and 00 star. Okay, so now let's do the construction. So let's start from the node. So first we will start with 0, 0 0. This is R1. Now let's R1 and R2 is also 0 0. So R1 and R2. Okay. Now we have R3 as 1 0. 1 0. This is R3. Now, this 2 is done, R3 is done, R4 is 0 star, 0 star. So this is R4. So R4, R5 and R6 is 0 star. So we will mark it. So this node will have R4, R5 and R6 marked. Then R7 is star, the root node. This is R7. So I have marked everything, no? R1, R2, R3, R4, R5, R6 and R7. Now let's build the D2 try. So from here we will have a dummy. Let's put the dummy here. From here we will have a dummy. Here again we'll have a dummy. Here we'll have a dummy. Now for R1 the D2 prefix is 110. So this is 1, 1 and followed by a 0. Oh, sorry. One, 1 and 0. 1, 1, 0. So this is R1 for the second dimension. Now for R2, what is the prefix? It is 1, 1 star, 1, 1 star. So it's already here. So this is R2. Now for R4, okay, for R3. R3, the prefix is 1 star. So this is R3. For R4, 0, 1. So it is 0 followed by a 1. 0 followed by a 1. This is R3. Then, sorry, it is R4. For R5, it is 1 followed by a 0, 1 followed by a 0. So this is sorry, R5. Now R6 is 1 star. 1 star is this one. So this is R6. And for R7, it is 0, 0 followed by a 0. So this is R7. So this is how we construct a hierarchical trie. So till this point, it is D1, D1 trie. And after that, it is D2. Okay. Now suppose I get a packet with D1 as 0, 0 and D2 as 1, 1, 0. Let us see which rule does it hit. So the D1 is 0 and 0. So it comes here. Okay. So from here it will come here and then it is 1, 1, 0. 1, 1, 0. So the packet with such a prefix D1, 0, 0 and D2, 1, 1, 0 star will match with rule R1. So its corresponding action will be taken on the packet. Now if there is another packet with 0, 0 and 0, 0. D1 0 and D2 as 0 0. So we are here 0, we are here 0. But and we'll come here. But do we have a 0 0 here? No, we don't have a 0 0 here. So does this mean that this packet doesn't match with any rule? Zero 0 and D2 with when we come to here we couldn't proceed further, but this 0 0 D1 dimension 0 0 also matches R4 R5 R6 and R7 because it is a 0 0 is a subset or 0 star is a superset of 0 0 star is a superset of 0 0. Okay, so if we have, so we need to always check the other available prefixes, all the superset prefixes. Okay, so we cannot just tell that okay 0 0 we came here and after that there is no 0 0, so this packet doesn't match. No, that's not how it is. We have to, now we will, because we have a rule for 0 star, so we from here we will backtrack and go here. We'll go to R4, R5 and 6 and we will check if any of those matches here. So we'll go here and we will see if 0, 0 is there. 0, 1 is there, 1, 0 is there. 0, 0 is not there for 0 star also. Then we'll go again up. So from here we came here and checked. Now we'll again go up and check here with R7 because 0, 0 matches with star. Okay, that's the reason we are doing this backtracking. So now we'll come here and we will see, okay, yeah, we do have a 0, 0. So this matches with R7. So this particular packet matches with R7 and this one matches with R1. Any doubts here? All right. I can see Chandu have raised hand. You can unmute, right?
Ma'am, I'm afraid they misses this all are important live classes due to some technical issue. Can you get the recorded video of these classes
Yeah,
after ending of this class?
yeah, it's updated in the NPTEL Swayam portal, no?
Yes, yes, ma'am. Thank you. Yes, ma'am.
Right. Okay. So, any other doubts from anybody? I think you are able to follow, so I'm proceeding. Let's see one more example. Mm, R1 is the rule. We have D1 and D2, and the prefixes given are R1 is 100 star 00 star 10 star 0 star. R3 is 10 star 10 star. R4 is 11 star and 1 star, and R5 is star and 00. Okay, so here we will again start with the root node. We will do 0. First one, we will take the D1. We'll construct the try for D1 first. Then from R1, so it is R1. Yeah, 0, 0 constructed. R2 was 1, 0. This is R2. R3 is also 1, 0. R4 is 1, 1. And R5 is star. Okay, now we will construct for the second dimension. So we will add a dummy link first so that we can start the construction. Yeah, for now for R1, what is the dimension to prefix? It is again 0, 0, 0, 0. So this becomes R1, 0, 0. For R5, the prefix is again 0, 0. For R2 and R3, R2 it is 0, 0 star. This is R2. R3 it is 1, 0, 1 followed by 0. So this is R3. For R4 it is again 1, 1, 1, 1. So this is R4. Okay. Now, so this is the again one another multi-dimensional trie that we have constructed. Okay. Now, assume that we have a packet that comes with 1, 0 and 0, 0, D1 and D2. Okay. Now, assume that we got a packet whose D1 prefix is 10 and D2 is 00. So now as per this try, how the packet will go, it will go from here to here 10. We have a match. It could be either with rule 2 or rule 3. Now we have to have a 0 followed by a 0, right? So it doesn't, there is no 0 followed by a 0, but there is a prefix that is matching it. So we have R2 here. Okay. So now let us assume that we got another packet which is, can anybody give me an example where I need to backtrack? Yeah. So another example, 1 star followed by a 0 star. So now if I get a packet with D1 as 1 and 1 star and D2 as 0. So with 1 star we will go we will go here and go here. So R1 will match for dimension 1. Then when we go for dimension 2 it is 0. But this is not matching, right? So this is on 1 is what we have. So what we have to do is whenever we find a mismatch, we cannot tell that okay this doesn't have a match, it doesn't match with any of the rules. We have to see if there is any other rule for D1 which is a superset of 1 star. Do we have any other rule which can be a superset of 1 star? We have star here, right? One easy way to check is here, this is where 1 is. Just check if there is any parent which is also a prefix. If there is any parent for R4 which is also a prefix, which is also a prefix which is marked here. So we need to have the label marked, okay? So for R4 we have R5 here up, right, in the top as a parent, which has a rule or a prefix marked here, right? So this is one way of looking at it. Another way is we can look at the prefixes and identify. Every prefix will be a subset of star, or star is a superset, so everything will fall under it. So now we are here and we saw that after R4 we don't have a 0 star. So we need to backtrack. We need to go up, again go up. We'll reach R5. From R5 we will come here and we'll see if there is a 0 star, 0 available. So here we have a 0 star. Okay. So this will match. So this rule will match to R5. Okay. So this is how the multi-dimensional trie works. But one difficulty with this multi-dimensional trie is that, yeah, we have to do this backtracking to ensure that we are checking like the packet. We cannot just say no just by one round of tracing and say that the rule doesn't match. We have to see all the combinations. So for that, multi-dimensional trie requires backtracking, which is actually backtracking requires a lot of time. It eats up a lot of time. So the search complexity increases, and due to that, an optimization is applied on this multidimensional trie known as set pruning trie. So that help us reduce the prevent this backtracking. So that is what a set pruning trie does. So what it will do is, the idea is that, so we know 1 so when you come at R4, if you have a D2, dimension 2, which is matching with R4, packet will match. In addition to that, we need to also check if there is any superset of. So now we backtrack till R5 and the R5's D2 is what matched. So what we do is in set pruning, we will bring this component also here, also to this part, so that after 1 will be available in this thread, 0 will be available in this thread, so that in this trie, so that the backtracking can be avoided. So what we do is we actually duplicate this particular part and add it here also. That is set pruning trie. So one as very obvious, since we are duplicating the node, there is a storage overhead here. We'll see an example. This is yeah. Let's say take a simple example. D1 and D2. R1 is 0 0 star, and 1 1 star. R2 is star followed by 1 0 star. So first we will draw the multi-dimensional trie and then we will do the set pruning. Okay. So we will start with a 0 root node 0 0 star, which is, yeah, please, you can unmute and talk. Okay. If you have any doubts, you can unmute yourself and ask, or you can type it in the chat. Okay. So this is R1 0 0. The other one is R2. Okay. So this is R2. Now for second dimension, R1 is having, so we will have a dummy link for the second dimension. This is 1 1 1 1. This is R1, and for R2 it is 1 0 1 0. This is R2. Yeah, so now in set pruning, what we do is we will, for every rule, we see the first dimension and we will check if there is any other prefix that will also match with this. So typically we need to see if R1 prefix is a subset of any other prefix, or if there is any superset available. And one easy way is to just track back to the root and see if there are any prefix marked nodes available. If there are prefix marked nodes available, when you are so from R1 move till the root of the tree. Right. So if there is any prefix marked node available, okay, so this is a superset. So the prefix corresponding to this particular node should also gets added to R1. Okay, that's what we do with set pruning. So what is the prefix associated with R2? It is 1 0 1 0. Oops. Mm, 0 R. Okay, so this node that I added, maybe I will add it in a different shape. Yeah, this one that I added is actually this copy of this. It's a copy of this one, right? That I have added here, so that we can ensure that we don't need to do the backtracking. Now, if we get a destination with a packet with D1 as 0 0 and D2 as 1 0, we will go 0 0 0 0. We will come here. Then we have 1 and 0. So we will match it with R2. Otherwise, without this set pruning, what we had to do was we had to go to do the backtracking, go to R2 and then come to R2. So we prevent this backtracking by adding this additional nodes. Okay. So this is one example. Maybe we'll see one more example. So this comes at the expense of cost. Maybe we'll see another example. Suppose 1 1 star D1, a packet comes with the D1 as 1 1 star and D2 as 1 0 star. Now let us see, 1 1 star is 1 1 star is here, and 1 1 star will match with this only, star only. It will not, we don't have any left side. So 1 1 star will match here, and we have a 1 0 star here. Okay. So this will match with R2. Now if we have a 0 star, that we already saw, it matches that. Okay, now let's see another example. Right, R D1, D2, D1, D2, R1 plus 0, 0 star, 0, 0 star, R2 is 1, 0 star, 0 star, R3 is 1, 0 star, 1, 0 star, R4 is 1, 1 star, 1, 1 star, and R5 is star followed by a 0, 0 star. Okay, now let's have the trie. Let's construct the set pruning trie for this particular rules. Okay, so first let us start from top. So we have R1, we will always start with D1. We construct the trie for it. Then we add a dummy node to the second trie. So it is like a hierarchical trie only. We just add additional nodes to avoid backtracking. Okay, so first we always construct the trie for D1. Then we construct the trie for D2. Then we go with the set pruning. Okay. So here double 0, 0, 0, 0 star is R1, R1. R2 was 1, 0 star, 1, 0. This is R2. R3 is also 1, 0 star. So this is R3. R4 is 1, 1. This is R4. R4. Then R5 is star. Okay. So this is R5. Now let's have the dummy node for all these marked prefixes. Okay. So for R1, now let's construct for D2. It is again 0, 0 star. 0, 0 star is R1. Now it is for R2, it is 0 star. 0 star for R2. And for R3, it is 1, 0 star. It is 1, 0. 1, 0 star for R3. Now for R2, R3 we are done, and R4 is again 1, 1 star. This is R4. R5 is 0, 0 star. 0, 0 star. Now we need to do the set pruning here. Okay. So we have to now check for R1, which other rule will R1 matches. So R1's D1 is there, no, 0, 0 star. We need to check if it matches with any of the other available prefixes. So one way is to check that. So 0, 0 star and star, of course, it matches with R5. So we have to add that D2 to R1 also. Okay, so we have to add the D2 of R5 for here for R1 also. And one way is to check like this. If 0, 0 matches with any of the other prefixes, or you can just go from R1, traverse up the trie and see if there are any marked nodes on the way to the parent. If there is any marked node on the way to the parent, then add that node for this of R1. So when we are going up to the parent, okay, R5 is here, which is a marked node, so prefix is there. And then you mark that particular R5's D2 for R1. So R5's D2 is 0, 0 star only, so we already have it. Okay, so this time we don't need to, we already have it. Now for R2, for R2, yeah, R2 is 10 star. So 10 star will match with star. Okay, so we have to add 00 star for R2. So 0 is already there. Just add one more 0 and this becomes R5. So this is the added node, this one. So this one and this one. This is the added R5. Okay. Now for R3, we have yeah 10. Same way, yeah, in the it matches with star, right? It matches with star. So if a prefix matches R3 and come to this dummy node, it should be in a position that even if the D2 of R2 and R3 doesn't match, we should be able to match it with the D2 of R5, because R2 and R3 are subset of R5. The prefix is a subset. So for R3, okay, we have already added 00 R5 here. So it is done. Now what is left for R4? Okay, so for R4 again, R4 also matches with star, right? So we have to add 00 here also. So this becomes R5. R5. So we have added two. These are the added set nodes as part of set pruning. Additionally added nodes. Okay. So this is how set pruning works. Let me see question. Yeah, like this question is from previous year's assignment. Okay, so let's do this. So there is the question is, consider a two-dimensional rule set as shown in the table. Okay, I will write the rules here. R1, D1 and D2. R1 is 00 star, R2 001 star. R2 is 00 star, 01 star. R3 is 10 star, 10 star. R4 is 11 star, 101 star. R5 is 1 star, 0 star. And R6 is 0 star, 10 star. And R7 is star, 11 star. Right. Okay, let's 0, 0, 0, 0, 1, 0, 0, 0, 1, 0, 0, 1, and restart. Alright, let's try the set pruning. Okay. So the question is to build the set pruning. Set pruning try. Which of the following rules are, which rules are duplicated? Okay. So let's build the trie. So let's start from the top. Maybe, yeah, 0, 0, 0. This is R1. Now R2 is again 0, 0 star. So this is R2 also. R3 is 1, 0. This is R3 and R4 is 1, 1. This is R3 and this is R4. Now R5 is 1 star. So this is R5. R6 is 0 star. This is R6. And R7 is star. Okay. Okay, so for R1, the second dimension is 0, 0, 1. 0, 0, 1. So this is R1. R2 is 0, 1. 0, 1. Okay. Now, yeah, for R3, it is 1, 0. Where is R3? R3, it is 1, 1, 0, 1, 0. This is R3. Okay. R3 is 1, 0. R4 is 1, 0, 1. 1, 0, 1. 1, 0, 1. This is R4. R5 is 0 star. Where is R5? R5 is 0 star. Then R6 is 1, 0 star. Where is R6? R6 is 1, 0. 1, 0 star. R7 is 1, 1. 1, 1. 1, 1 star. Okay. Now we need to see which all nodes we need to duplicate. Okay. Yeah. So let's take one by one. So 0, 0 star is a subset of this one and this one, right? 0 star and star, R6 and R7. So we need to have these two under this. So we need to have 1, 0 and 1, 1 here. So we need to have 1, 0 and 1, 1. So this will be one diamond, this will be another diamond. Okay, this is R6 and R7. This is 1, 0, this is 1, 1. R6 and R7. Okay, now for so that is, so we are done with R1 and R2. Now let's see for R3. 1, 0 is there. So 1, 0 will be a subset of 1 star and star. So let me check this. So R3, that is 1, 0, is a subset of 1 star and star. So where is R3? By the way, yeah. So here we need to have, so under this link, we need to have both 10 and 11 star. So we already have 10, so we have 11 star. So what is this? This is R7. So we duplicate R7. Oh, sorry, 10, this one, 0 star. I got it wrong. So what I meant was we this R3, that is 10. 10 is a subset of 1 star and star. So we need to have 0 star and 1 star under this. So we don't have 0 star. So we need to add 0 star. We are adding 0 star. So which is this diamond? This is R5. This is R5. So that this diamond we add as part of set pruning. Okay. So we are done with R3. Now R4. R4 is 1 star. So 1 star is a subset of again 1 star and star. 1 star is also a subset of 1 star and star. So for here, so for R4 also we need to add 0 star and 1 star. So 1 star, 1 star we have to add. Then we have to add 0 star. Okay. So this is R5. This is R7. Okay. Now R4 is done. Now R5. R5, 1 star is a subset of star. There is R5 in this, yeah, this guy. So here we need to add, this was only 0 star. Now we need to add a 1 star here. And this will be our R7. Okay. So this is R7. Now for 0 star again, R6. R6 is also a subset of R7. So where is R6 in this? This one. So here again we need to have R7. So what are the diamonds we have added? We added a diamond R6. We added diamond R7. So we added R7. R5 we added here. So we added till now R6, R7 and R5. Then we added R7, here R5, here R5, R7, then R7. Okay, so what are the nodes that we have duplicated? We have duplicated R6, R7 and R5. Okay, is this clear? So as part of set pruning, we have duplicated these nodes. Okay, any doubts?
Hi, ma'am. Can you brief
Yeah.
about this, please? Actually, I just now I joined.
Oh,
Yeah, please. Can you brief about this, please? And
so
one more
right.
thing I
So
wanted to ask you is for 20th April about exam, they have told that 9 to 5 is 9 to 12 is one session and 2 to 5 is another session. So, what kind of like a multiple choice questions only it will be there, or
I have no idea about the examinations. That query, probably you can put it in the, there is another, some Google groups is there, right?
no, it is not there.
There is a Google group. You can go and check in the Swayam portal. So you can see there, ask a question. There is a tab actually
Okay.
wherein, or probably just wait, I can show you the tab. Okay, so once I'm done with this handwritten thing, no, I'll go back to MCQs. So that time I'll share from my laptop and I can show you the portal where you can put those query. So we are taking only those problem solving sessions. The other actual TAs that work with the professor will be able to help you out with that, how the exam pattern will be and all that.
Yeah.
Okay. So you want me to quickly brief this?
Yes.
Yeah. So, okay. Question once again. Okay, I think I'll do one thing. I'll brief this once with a simple example and then I'll again ask the question. Okay, give me a minute. So back to the simple try. All right. So let me go back to that simple example wherein what is it? Yeah. Yeah, so if you see here, like this is a multi-dimensional trie that was generated for this particular set of rules, okay, from R1 to R5. Hmm? So you can see R5, so we start from R1. You know how we generate the trie, right? So for R1, for each dimension, we generate the trie and then we link them with this particular dummy link. Using the dummy link, we link them. That's so one trie over the other. That's the reason we call it hierarchical trie. So first till this point, it will be D1's trie. Below that, it is D2's trie. So for dimension 1, we have 0, 0. This is R1. Then first we construct for dimension 1, then R2 is 1, 0, 1, 0 is constructed here. Then R3 is again 1, 0, R2 and R3 is here. Then R4 is 1, 1. Okay, so this is where R4 is. R5 is star. After that, we take the dummy node from all the prefixes R1, R5, R2, and R3, R4. Then we construct in the similar manner, we construct D2 also. So for R1, it is 0, 0, 0, 0. R2, it is, where is R2 here? Yeah, it is 0 star. Then R3 it is 1 0 1 0 and R4 it is 1 1 1. Okay. So now the example here is that now if suppose a packet comes with the prefixes of 1 0 and 0 0. So D1 have the prefix of 1 0 and D2 has a prefix of 0 0. In that case, how we will traverse this trie? So we have a prefix of 1 0, we come here 1 0, we come here to R2. Okay. Then after that, what is the prefix that we have? Is this 0 0 or 0? Yeah. So yeah, the prefix is 0 0. So it will come here. So this is it. But and one more 0 is not there, but it is a prefix node, right? So this rule will match. Okay. So this packet 1 0 D1 and D2 0 0 will match with R2. Okay. Now if another packet comes, if the other packet is with prefix 1 1 star and 0 0 star. So this rule we will go here. 1 1 star is this one. R5 say we go to the right and we reach R4. Then from R4 we have 0 0 star. But we have only 1 1 star. We don't have 0 0 star here. Right. So we cannot tell that. Right. This is how it is. So there is no 0 0 star at R4. So does it mean that this packet doesn't match with any rule? No, right? Because 1 1 star also matches with star. And star have a 0 0 star D2. So what we have to do is even if we don't find the rule, we will go back, we will traverse back up till the root until we find another prefix. So we go up, we reach R5, then we come here and here 0 0 is found out, right? So it matches with R5. Hmm? So this is what is called as backtracking. So this actually consumes a lot of time when we are doing the lookup and processing. So to prevent that, what we do is, so from R4, I had to backtrack And then I came here all the way R5, and then we got the matching rule, right? So to prevent this backtracking, what set pruning does is this particular, so whatever will match, so whatever lower order prefix, that R4 will match. Okay, we can tell that whichever prefix that is a superset of R4, that also should be added as a try or as a child here for R4. So what we do is we add this one, this R5, we add it and bring it here. So this is what we were doing in set pruning. So we added this 0, 0 star here and I marked it as a diamond for R5. So instead of going back from R4 to R5 and then getting into the rule, this is backtracking. We actually duplicate this near R4 itself. Okay, so whenever, when we are doing the set pruning, whenever you get a D1 rule prefix, check if this prefix is the subset of any other available prefix. If it is a subset of any other prefix, then its dimension also should be present as in your try. Okay, so that is what we were doing here. So in this question, the question was we are given this particular rule R1, R2, R3, R4, R5, R6 and R7. Okay, and we were asked to build the set pruning trie for it. And after building the set pruning trie, so when we do a set pruning, we are actually duplicating certain rules, right, to prevent backtracking. So the question was which were the rules that we duplicated as part of set pruning. Okay, so we were duplicating rule number R6, R7 and R7, R5. Is that clear? Then I'll move to the next topic. It was 7. Okay, so with the set pruning, yeah, thanks. So with the set pruning, we can actually prevent backtracking, but this is at the cost of memory, right? So in worst case scenario, we may have to duplicate a lot of such nodes, right? So another enhancement to this is what is grid try. Okay, another enhancement to this is grid try. In grid try, what we do is instead of duplicating, so here what we did here, for example, let's take this R6 thing. Okay, so here we added one more node, right? 1 star for R7, right? Instead of adding this, what we do is we already have R7 here, right? What we had was we had 1 0. What I additionally added was 1 and then this R7. So what we do is instead of doing this, adding it as a node, we just add a link from this node to R7, marking 1. So we are not duplicating this node anymore. So that is the logic of grid try. Okay, we will see. First we'll probably start with a simple example. Okay, so one example is R1, R1 R1 is 0 star, R2 0 star, D1 and D2, R2 is star and 1 star. Okay, so now we start from the top, 0, 0, this is R2, this is this is R1, this is R2, right? Now, so for this we need to build the multi-dimension trie. So we will build the trie first. So for R2, okay. Yeah, for R1 now, which is the prefix 1 0. This is 1 0 1 0. This is R2, sorry, R1, and this is 1 1 star, 1 1 1 star, which is nothing but R2. Okay, so now we have to prevent backtracking, we have to do a set pruning, right? So 0 0 star is a subset of star. So we have to add the corresponding prefix of D2 prefix of R2 for R1 also. So we have to add one, we have one here. So what additional one we will add as part of set pruning is we will add a one, right? One is already there here. We add a, and then this is what we do as part of set pruning. We will add R2 here so that 1 1 star will work. So now with grid try, what we do is instead of adding this, instead of doing this, what I will do is I will just add a link from this node. I will not do this. I will not do this. We will just add a link from here. So now if I get a packet with 0 0 star followed by 1 1 star, we will track come here 0 0 star, okay, will come, will reach here. We have 1 here and we have 1 here. We'll reach R2. So this is the logic of grid try. So instead of duplicating the node, we are just adding a link because node is already there. We just have to add the link and tell for which 0 or 1 I should take that link. So that's what grid try is doing. Okay. So this is the enhancement over set pruning. We'll see one more example. Okay, so the rules are we have D1 and D2, D1 and D2. R1 is 0 0 star, 0 0 star. R2 is 1 0 star and 0 star. R3 is 1 0 star and 1 0 star. R4 is 1 1 star and 1 1 star. R5 is star followed by 0 0 star. Okay, so let's build this try. So first let's start with 0 0 0 0 0. This is R1. Next is 1 0. This is R2. This is R3 also. Okay, then R4 is 1 1. This is R4 and R5 is star. Okay. Now let's start the next one, second level, D2 try. So let's add this dummy link. Then okay. So for R1 again it is 0 0. This is R1 0 0. For R2 it is 0 star, 0 star, R2, and R3 is 1 0 star, 1 0. So this is R3. Now R4 is 1 1 star, 1 1, 1 1 star, R4, R5 is 0 0 star, 0 0 star. Okay. So now let's see how we need to add the two. Okay, so let's take R1. Is R1 a subset of any of the existing prefix? R1 is not a subset of 10, 10, 11, but R1 is a subset of star, right? Hmm? So, whatever is the dimension, second dimension present in R5, that should be there in R1 also. So, we see that this is 0, 0 star, already have 0, 0 stars, there is no issue, so nothing to be added. We had that. Now, for R2, let's take 1, 0 star. 1, 0 star also matches with star, right? 1, 0 star is also a subset of star. So, what is it that it should match? It should match 0, 0 star, but it matches 0 star. So 0 star and 0, 0 star, the same, right? No, but if it is 0 star, it could be 0, 1. 0, 0 star is 0, 0 followed by 0, 1, 0, 0, etc. Okay. So for R2, we have to have 0, 0 star. So which one is 0, 0 star? So we add a 0 followed by another 0. We add a link to here. So maybe I should use some other color to represent the link. Oops. What we do is we add a link here. Okay. For 0. Now for R3, R3 again is a subset of star. So we need to have 0, 0 star under R3. So this is already R3 will be coming to this place. So if I have a 0, 0 star, yeah, it is already taken care. Now for R4, it is 1, 1 star, right? So R4 also is a subset of star. So we need to add a link for 0, 0 star. We cannot just, so intermediate node we need to add here. So we add an intermediate node of 0 and then the second node to 0 to R5. Okay. So we have two links now added. Okay. One from R2 and the other from R4. Okay. So this is a grid try work. Instead of adding the R5 node, we just add a link to the existing node. Okay, this is how grid try works. So this is one example. There is a question is on the other one. Okay, I'll quickly move to the other. It's already 23. Screen. Yeah, let's look at the other try also. Field level trisector. It's a different representation, okay, wherein it's not in the try formation. So we don't start it from with the prefix in that way, but we started from taking the set of all rules, assuming that as if there is a star rule and we take on the root node all the rules. Then as the prefix comes, we add one by one node to it, and each node can have multiple rules associated with it. So that is how field level try work. We'll see an example, and there is a question in the previous year from this section, so we'll discuss that as well. So let's see the example. R1 is 0, 0 star 1, 1 star. R2 is 0, 1 star 1, 0 star. R3 is 1 star 0, 0 star. R4 is star, 0, 1 star. Just a minute. Okay. Yeah. So we start with having all the rules in the root node R1, R2, R3, R4. Okay. Now we see the prefixes one by one. Okay. So first we will see the D1 prefix. So D1 0 0 star. 0 0 star matches for which all okay. So 0 0 star will match for R1 as well as R. Yeah. So we start with R1 and then we add 0 0 star, and in that we add all the rules. So R1 is a subset of R4 also, right? So we add R1 and R4 here. Now for R2 0 1 star. Same way R2 is a subset of R2 and R4. The next one is 1 star. Again, R3 is a subset of R4, R3, R4, and then star, we have R4. Okay, now we look at the second dimension. So, second dimension for R1 is 1, 1 star, 1, 1 star. So, this is R1. Second dimension for R4 is 0, 1 star. Now, which is the for R2 and R4, which is the second dimension for R2? It is 1 0 star. 1 0 star. This is R2. Now, for R4 is also there, so we make a link here. This is 0 1. Now, again for R3, 0 0 for R3, and for R4, we map it here. Then again, same here. Okay, so this is one another representation of, this is like field level representation. Okay, so here we are starting from the set of all rules, and then one by one we are going with the prefixes. So if this prefix comes, which all will match. If this prefix comes, which all rules would match with this. If this prefix come, which all rules would match with it. Okay. So if 0 0 star comes, R1 will match, R4 will also match, right? Because star is a superset. Same way if 0 1 star comes, R2 will match, R4 will match. So one by one we mark all the rules that match with each of this prefix and build that rhyme. Okay. So this, and there is an example from the last year's question. Let's take a look at that. Okay. So the question is. Consider the four-dimensional classifier. I think before that it will work. It's okay. There is this rules given. It's a actually four-dimensional rule. Okay. So let me see if I can copy and paste this in the chat. Okay. So it's R1, R2, R3, R4, R5, R6. So D1 is 1 1 star, 1 1 star, 0 1 star, 1 star, 0 star, and star. D2 is 0 0 1. Star is there, I'm not mentioning, okay. D3 is 7, 2 comma 6, 3, 9, 1 comma 5, 10. 1 second. D4 is 9 comma 12, 15, 7, again 15, 10, and 12. Now the question is, consider the four-dimensional classifier with 6 rules shown like this. Suppose node X is associated with the prefix 1 1 star in the field D2. Which of the following rule set does node X contain? So what they are asking is, there is a node X for the second dimension field. Okay. So this is the somewhere like this. There will be a node like this for a particular prefix 1 1 star for the in the field D2. Okay, so for that node, what are the rules present inside that node? So if suppose for this node, what are the rules present in R1, R4? So we have to first construct this and then find out what is the rule present there. Okay, so let's start with R1, R2, R3, R4, R5, R6. Okay, so first it will be R1, R2, R3, R4, R5, R6. Okay, so for R1 we have 1 1 star. Now let's see which all would match with R1. 1 star is a superset. Star is a superset. 1 1 star. Okay, R2 also. So with 1 1 star, what all will be inside? R1, R2, this will match R4 and R6. Okay. Now for, so 1 1 star is done. Now this both is taken care. Now R3. R3 is 0 1 star. So for 0 1 star, which all will match? R3 will match. 0 star R5 will match. R6 will match. So we will have R3, R5 and R6, right? R3, R5 and R6. Now we have 1 star. For 1 star, which all will match? R4 and R6. 4 and R6. Same way 0 star will match with R5 and R6. And star will match with R6. Okay. Now this is done with the D1 is done. Okay. Now we have to go for D2. So what is the, so D2 it is 0, 0, 1 star. For R1 this is 0, 0, 1 star. So 0, 0, 1 star. Right. So 0, 0, 1 star is a subset of 0, 0 star also, right? So when you write 0, 0, 1 star, R1 will come plus 0, 0, 1 star is also a subset of 0, 0 star. So R2 will also come. Now for R2, we have 0, 0 star. So there are no other subsets for it. So R2, 0, 0 star. Then for R4, we have 1, 0 star. Yeah, we have 1, 0 star for R4. Now for R6. For R6, we have 0, 1 star. 0, 1 star. Okay. Now let's take R3. R3 second dimension is 1, 1 star. 1, 1 star will match with R3 and R5, right? R5 is 1 star. So 1, 1 star will match with R3 and R5. So 1, 1 star will have R3 and R5 inside it. Okay. Now R5 is having 1 star. So 1 star will match with only R5. R6 has R6 have 0, 1 star. So we can give a mapping from here. Okay. We can give a mapping to here. We don't need to again draw it. Same way for R4. R4 is 1, 0 star. 1, 0 star will match with 1 star, right? 1, 0 star will match with 1 star. Yes or no? Okay. So the question was whether I don't think we need to construct the full trie. We have already got the answer, right? The question was which is the for the node x that is associated with prefix 1, 1 star in the field D2. So which is the node associated with 1, 1 star in D2? Which is the node here which is having 1, 1 star? This node, right? So these are the nodes of after applying D2. This is all D1. These are the D2 nodes, okay? So for 1, 1 star, the node associated with 1, 1 star is having which all rules in it? R3 and R5. Okay. To answer it, we actually don't need to construct it fully. It's actually will become little longer, so I'm not constructing it fully. If you want, you can try it out. Okay. Yeah, now this is again R4 and R6, right? So R4 we will give it to if you want, okay. This we will link it here, R4 and R6 will link it here. Again R5 and R6, right? R5 will go here, R6 from R6. Now from this, now this was D1. Now next will be D3. So D3, what was the number? 7. 7 will go to R1. 2 to 6 will be R2. This will be 7 will go to R1. 2 to 6 will be R2. Same way here 2 to 6 will be R2. Then 3 will be R3. Where is 9 was R4. 1 to 5 was R5. So there is this R5 3. So what we do is we will omit that. So here we also have R5, right? So 1 to 5 is R5, but we have a more specific field with specifically for R3. So this here we will add only 3 will go to this one. We will add 1 to 2 and 2 to 4 to 5 to R5, and from here it will be 1 to 5. Then further similar way all this node, okay? So all this node. Now last one is 9 to 12, 15, 7. R1 is 9 to 12. 9 to 12 is R1. R2 is 15. R3 is 7. R2 is 15. R3 is 7. Then 15, 10 and 12. R4 is 15. R5 is 10. I missed R6 in the previous iteration. So this was 10 actually. Here we missed it. R6. This is 10. So R6 is 12. So this is the full try, okay? This is together, not separate. R3 and R5, and because why it is together is R3 and R5 was already together, and if you see this is 2 to 6 and 3. This is not this one, this one, this and this. It's already a subset, right? So that's the reason. 1.5 is 1 to 5 is a superset of 3. So that's why this is all also together here. Okay, so that was one question. Right now, another concept that was discussed regarding which there is a question is there is in the class some heuristic algorithm for packet classification was also discussed. So the motivation there was majority of the rules would have like similar like rules will be with similar source destination IP address with maybe the port numbers varying and all that. So instead of repeating this common fields, right, there is one can try to associate an ID with these commonly occurring fields, and that will further help to shrink the size of these tables. Okay, so let's see an example and try to understand what is meant by that. Okay, so it's an approach again. So for example, if we have a rule R1 with one dimension as 10 dot 10 dot 10, and the port, this is D1, that is destination IP, and this is destination port. So this is destination IP, destination port as 80. R2 is again 10 dot 10 dot 10 dot 10 with destination port as 25. R3 is again 10 dot 10 dot 10 dot 10 with port number 21. R4 is 20 dot 20 dot 20 dot 20 with destination port 80. R5 is with port number 21. R5, R6. Again 20 dot 20 dot 20 dot 20. Port number 25. So the actions given are, one is send to port 3. This is drop. This is again sent to port 3. This is sent to port 11. This is drop and this is drop. Okay. If such a if such a what is that? Such a rule is given, we can see that a lot of the IP destination IP address part is actually common, right? What is differing is the action and the port number. So what this heuristics or this approach tries is the common, we try to assign some identifiers to this common part so that we can reduce the number of bits that must be repeated in this table. Okay, so first thing, so we have these three things common across the rules, and this is common. So unique IP addresses, if we see, it is only two, right? 10 dot 10 dot 10 dot 10 and 20 dot 20 dot 20 dot 20. So what we will do is we will assign a unique ID of 0 to this and 1 to this. Same way, if you see the ports, we have only three different port numbers, 80, 25 and 21. The rest of it's repeated, 80, 21, 25. So here again, if we can give some ID, 80, 25 and 21. If we can give an ID, three are there, so we need to use 2 bits, 0, 0, 0, 1 and 1, 0. Now again we will represent the actions also similar way. Let's give some number to the actions. Like send to port 3, let's mark it as 0, drop as 1, again send to port 3, 0, send to the 2, right? So we can represent these. So this big table, we can transform it. We can replace it with these IDs. So the first R1, R2, R3. It will be 0, 0, 0 in place of 10, 10, 10, 10. R4, R5 and R6 will be 1, 1, 1. Okay, now if we again go with port number, if we go for 80 is 0, 0, 0, 1, 1, 0. Similarly, 0, 0, 1, 0. 21 is 1, 0, 25 is 0, 1. And the actions, if we take, we gave action 0, 1, 0 to sending to port 3. Sending to port 3. The next one is 1. Again, sending to port 3. This is dropped, right? That was port 11. drop was 1, 1, 1. So it becomes transformed to a much smaller size, right? So it's an approach for reducing the size required for the representation. There is another question on similar line. Let us just quickly see that. Yeah, the question is, yeah, this is the rule R1, R2, R3, R4, R5, and R6. So this is star, this is port number equal to HTTP. This is range 20 to 21. This is equivalent to HTTPS. This is 53 and this is greater than 1023. So, so the question is, how many bits are required to express the this port number field into an equivalence ID? If we try to represent the port number as an equivalence ID, how many bits are needed? Okay, so star will comprise of uh, everything, right? So let's first come with this one. What is this? Equivalent to HTTP is 80. 20 to 21, it equivalent to HTTPS is 8, 443. Now 53 and everything greater than 1023. So in the star, so there is a rule saying everything greater than 1026. So under star we will consider everything less than 1023 excluding all these port numbers. Okay, so we will come up with the equivalent class. So what we will do is we will put the first class as 20 to 21. Okay, we will make it as 0. Then HTTP, then we will put R5 53. This will become 1. Then we will go for, so this is done, this is done. We'll go for this, that is 80, which is 2. This is 43, that is 3. Now everything greater than 1023 will be 4, and now the rest of the thing. So what are the rest of the things? We have 0 to 19, 20, 21 is there, 22 to 52, 53 is there, 54 to 79, 80 is there, 81 to 442, then 444 to 1023. All of them will form in one class, which is 5. So how many bits do we need to represent the? We need 3 bits, right? For the given different set of port number, if we map it to an ID, equivalence ID, we have 5 different equivalence ID, right? 5 different IDs. So to like to represent 5 numbers, how many bits we need? We need 3 bits, okay? So the number here is, so the answer here is we need 3 bits to represent them. Okay. Is this clear? So there was some question here in D2. Should R410 Y rule will be not R4 and 5 but only R4. No, see the rules that are this doesn't the because we cannot just take it from the other subset. The initial uh, prefix should match, right? The initial prefix matched, and all those matching ones came together: R1, R2, R4, R6. So further on, only these four will be under this set. Okay, even though if I this 110 star, what is your query was R4 and R5, right? Yeah, 10 star and 1 star are subsets, but the previous one star and 0 star were not. Okay, so so the first dimension should match. So within that, you have to see the second dimension. Okay, I think I didn't make it clear that time. I think, is it clear now, whoever asked the query? Yeah, okay, good, thanks. Right now, maybe we can quickly go through the MCQ questions. And if time permits, yeah, we'll go to the MCQ questions. Okay, so the first question is, during the lookup operation, which of the, yeah, during the lookup operation, which of the following try avoids backtracking? Hierarchical try, set pruning try, grid of tries, and multi-level tries. So for hierarchical try, we saw that we need to have backtracking, right? Yeah. So for that only, to avoid backtracking, we brought in set pruning try. And to reduce the memory, we again further enhance for grid of try. So set pruning and grid of tries are the answer for this question. Okay. Which of the following try neither requires backtracking nor rule replication during the lookup operation? Hierarchical try, multi-level try, set pruning try, grid of tries. Any answers? Right. See, which of the following try neither requires backtracking nor rule replication? So, hierarchical try needs backtracking, set pruning try needs replication. Grid of try does not need either of them. So the answer here is D. So the next one is, consider a three-dimensional set pruning try with D1, D2 and D3 fields, and the maximum field length for each field is 4 for a 5 rule set. The worst case scenario, how many times will rules need to be replicated? So we the number of replication is actually in the order of w power d. Okay, so here which is nothing but the number of rules into the number of power, the number of dimensions. So it is 5 power 3, which is 125. Which of the following packet classification schemes is the most efficient in terms of searching time? Hierarchical trie, set pruning, grid of trie. So both set pruning and grid of trie are good with respect to searching time. So the answer is both set pruning trie and grid of tries are equally efficient with respect to searching time. So this is what we have seen in between. Consider the two-dimensional rule set shown in the table below. To build the set pruning trie data structure, which of the following rules will be replicated? So we have seen that R5, R6 and R7 was getting replicated. R5, R6 and R7. So which is nothing but the answer will be C, D and E. Which of the following statements is bar are correct? Integrated service provides guaranteed quality of service. I did not get into that part of the lecture itself. That was more on a theory part, right? So hopefully you will be able to go through the lecture and follow, I believe. Okay. So integrated service reserve resources on a per flow basis. Integrated service does not reserve resources on a per flow basis. An integrated service use RSPP to reserve the resource. So option A, is it correct or wrong? Option A. Can someone answer? So A is correct, right? Integrated service provide guaranteed. So they have three types, right? One is guaranteed, the other is I forgot that term. Then the third one is best effort. So that is how integrated service model work. Guaranteed, controlled load service and best effort. So it do provide guaranteed QoS. Then it does resource reservation on a per flow basis and it uses RSVP. So A, C and D are the right answers. Then yeah, this question I think we just saw, some time back. So for node X, what were the flows present? So it's R3 and R4. R3 and R5. Next one, Q8. Which of the following statements is bar are correct? In order to guarantee the quality of service, all packets of a flow must follow the same route. Packets that require guaranteed service will be served first before those that require best effort service. Is the statement correct? So in this Q8, which is correct? A, B, C, and D. So A says that in order to guarantee the quality of service, all packets of a flow must follow the same route. So that is true actually. So that the delay, everything, because you do a reservation for a particular path, right? So only if all the packets follow the same path, the guarantees can be met. So that is true. Packets that require guaranteed service will be served first before the best effort ones. That is also true. To prevent packet loss, the first of router may need to allocate a buffer for the source smaller than its purge size. No, all these gets taken care in the resource reservation. Control load integrated service class is used for delay intolerant applications. No, delay intolerant will fall under real time. So that will go for guaranteed. So A and B are correct here. Okay. So the answer is um, Yeah, consider a two-dimensional hierarchical trie with a depth of 5. What is the worst case search time for the two-dimensional hierarchical trie? Two-dimensional hierarchical trie with the, so 2D means the number of dimension is 2, right? Depth of 5 means the width of the prefix is 5. So W power D, which is 5 power 2, that is 25 is the worst case search time. Q10, I think we just saw that the answer is 3 here. Okay. So yeah, with this I'm pretty much done. So any queries, any doubts? Are you able to follow the session? Any feedback, any comments? Right. If there are no more comments, then we can close the session. Thank you all.
Thank you all.